Good afternoon, everyone, and welcome to today's webinar. My name is Alice, the Geospatial Marketing Product Manager, and I'm the host for this meeting. And today, joined by my colleague, Gray Yuan, the Geospatial Technical Support, and Benson, the EMEA Sales Manager, and we will share you the latest advancements and the best practices for FJD Trion scanners. And today's webinar we will include 4 parts. First, we will kick off with an in-depth introduction to the FJD Trion S2, including a live demo and real-world applications. So you are going to know its capabilities and know how this powerful tool can elevate your workflow. Next, we will explore how to optimize the results when you use S2, whether you are a new user or professional seasoned, and we will give you the actionable tips and strategies to help you maximize the efficiency and precision. Next, we will take a moment to brief review the recent updates. New key products, FJD Trion P1 and FJD Trion Model, and we will highlight the enhancement and what it means to your project. Finally, we will enter dedicated sections for the Q&A part, so you can ask any questions here. Okay, so let's start. So actually, FJD Dynamics just entered the scanner industry in 2022, and the S2, namely the second generation of the scanner. So what makes S2 different? And there are 4 reasons we want to highlight. The first is the higher integration. And S2 integrates the 2 cameras. You can see that with the 12 megapixels of each. And also, we no data logger anymore. We integrated the powerful CPU inside and also the RTK model. So the whole size will be smaller and it will be lighter. And it only likes 2 kilograms, and you can easily carry it to walk around like every surveying projects. The next is the multiple choice. S2 enables 3 modes. The standard one is 120 meters scanning range and with 320 points per second. And if you want to have a higher density, S2 Pro will double the point speed. And if you want to extend a longer scanning range, S2 Max will be your better choice. And next is the versatile compatible. And S2 not only can work as a device, it can seamlessly integrate with other platform. So we provide the extension pole, the robotic dog mount, the jaw mount to help you can seamless change between the platform like the aerial, the ground, or the handheld. And not only the device itself, we also dedicated on the algorithm optimization. So with the 2 built-in camera, S2 enables 2 very important functions. The first one is we can not only use the LiDAR slam, we also do the fusion of visual slam. So it enables the S2 to have a stable performance in some featureless environment, even some challenging environment. Another is that it can do the real-time colorization in your mobile phone, so you can see the every details in real time. Also, the S2 not only compatible with our ecosystem, the software. So the FJD Trion Scan real control app, you can use it and you can just grab the phone and your to do the preview. And also after that, you can import this raw data into the PC or the iPad to do the data processing. And later you got the result, you can upload to the online platform and share with your potential customers. Okay, so that's the features. And recently we have done a real demo in Singapore, and I have invited my colleague Benson to share his demo. And Benson, I will give you the floor.
Hey everyone, good afternoon. So I'm Benson from FJ Dynamics, and next I'll share about what this case I've done in Singapore, the background of it, um, how I have achieved good scanning of this case, and in the end, why we're doing this case. So first, this is a tunnel scanning for a metro, for a subway in Singapore. And we have scanned two point clouds in this scan. One is a 1.2 kilometer tunnel scan. Another one is 1.7 kilometers. The first one took 23 minutes and the second one took 28 minutes. These two scanning are connected with one station in the middle, and I use that station as an overlapping area to do the stitching of the 2 point clouds. And this was successful because after the scanning, the client checked the drawing and show that the scanning is correct according to all those drawings. So how did we achieve good scanning results in this scan? First, we need to secure an S2 max for this kind of scanning, especially in tunnel scenario. The visual points, they are repetitive in every single meter, and all of the tunnel looks the same. So you will need a stronger machine to capture as many feature points as it can to achieve a SLAM algorithm that works in the tunnel. The second point is that during the scanning, we not only want the LiDAR or point cloud results, we also want the video result so that we can recognize some specific utilities in the tunnel, like control panels, like electricity boxes, and even some words on the wall. So we want some lighting to make our videos readable and clear enough to show all these details in the tunnel. And that would require us to bring enough lighting and turn on lights, even though LiDAR itself can work without lights. And the third point is that to do this scanning, we want that overlapping area to be as much as we can. So we use the whole station as the overlapping area to stitch these two very long tunnel together. And the last point is actually one point that we did not do very well in this case because for each scan, we want you to stay within 20 minutes. Although we success during in this 23 and 28-minute scan, but a 20-minute scan is still the best recommendation for each scanning period. So after talking about how do we do this scan, and I will talk a little bit more about why we're doing this scan and what is the application of this scanning. So we can go to the next page. Right. So why we're doing this scanning is majorly because of the client, they want to do a digital asset management. In a very big company like the subway company, they have this enormous subway network underground, but they're very difficult to manage every asset within their underground, with including their railroad, their walls, their MEPs, their electricity boxes. Many of these drawings are scattered all around their different departments, and once changed, it's very hard to find where to find these kind of changes. So what they want to do is that they want to rescan this whole tunnel in the way of 3D and map and label every single asset that they have. So whenever there are changes or whenever they want to install some IoT devices, they can have a 100% accurate BIM model to support them to do all the maintenance and do all the smart changes and do all the afterworks. So this is one important point for them to do it. Another point is to do periodic monitoring. So it's a similar idea. If they want to scan this tunnel from time to time, and thanks for the flexibility of handheld scanner they can achieve scanning tunnel from time to time and compare the first point cloud and the second point cloud and see if there anything changed. The third reason to use is to do SBO verification. And this is all actually thanks to one of the new features that we have just launched in our software called sectional analysis. This function allows you to compare the as-built model, the design of the tunnel, with the assets and the design cross-section of the tunnel, and compare to the actual cross-section of the tunnel from every few meters, so that you can know what is the difference between the actual tunnel and the difference of the as-built. In this case, they want to know if there are any concrete falling from the wall, and they can directly know if anything is different from the designed cross-section already. And this is basically everything that I want to share with you about this case.
Okay, so thanks for Benson's integration. And next part, our technical support Gray will show you how the S2 performs in the real world. And Gray, I'll give you the floor.
Okay, so now let's see a live demo of our how to completing an S2 scanning workflow. Here is a video. First, let's start to scan. Press the scan button and enter the project name. Wait for the progress bar to lower to 100%. Please see where our letter is heading for. A good initialization point should have more features like angles and shapes. It's better that the surroundings can stay still. Let's see our scanner. The camera shows like this, a closed eye. The letterhead is rotating, scanning environment. The power button is blinking in red light. And now let's go to scan. Hold it in front of you and raise up slightly. Walk steadily until you want to stop. Put it on the ground stably and press Finish button on scan. Wait it to be saved at 100%. So this is a total live demo of how to use our S2 scanner. So first is the preparation. What do we need to do before starting the scan? So first you have to download the trim model and trim scan from our website. We also put the links here, attach the links here. And you should check all your accessories that you need in your working situations, like camera. Do you need camera, or do you need the smart decay for geological data? So next, let's turn on the S2. In the first time you're using S2, it is set to connect with the scan by hotspot and Bluetooth for the first time. So you will enter your past hotspot informations in the mobile phone. Here, please note that the name and the password should be easy enough for our scan to recognize, because otherwise Sometimes complex hotspot name and password may lead to unstable connections. However, if you want to change to Wi-Fi mode, which is also called the AP mode, you can doing it by short pressing and long pressing the power button. When the power button is blue light blinking, it means your mobile phone can search its Wi-Fi. The Wi-Fi ID is the serial number of S2 and the password is FJD Trion S2. No caps. Okay, so when everything is ready, it's time for outdoor scanning or indoor scanning. For ensuring an efficient scanning, route planning is needed. Here, I listed 4 nodes which can do good to your future works. First, when you have a large region to scan, you can divide them into several sections, and each of them can share 20% same parts. Just like the Olympic rings, they have the same parts shared. By using the continuous scanning, you can merge these sections together without big errors. I know that S2 can support for scanning a long time, but we don't suggest you to scan it for 1 hour or 2 hours. That will accumulate unexpected big errors. So second, find a good place for initialization. As we mentioned in the live demo, the layer head should head for a region which has more angles and shapes. Yeah. Like I showed on the left, this white building with holes. This is a good initialization point for layer head to capture. And just never head for a road with moving cars. Moving cars is not good enough for initializations. That will cause some ghost shadows. Third, close the loop in 5 to 10 minutes. Long-time scanning without closing the loop will accumulate unexpected accumulating errors. And this will do harm to your data quality and accuracies. Fourth, if someone is nearby or somebody just want to see, oh, how are you operating your scanner or how do you do the scan? You can keep a distance between you or let them follow behind you. Do not let them appear in front of our scanner. And after we click the complete button, it starts to save the data. During this time, put it stably on the ground or somewhere undisturbed. Until it finished, don't turn off the scanner immediately. I suggest you to go to the File page on Scan and to check the preview data is okay. This is quite important. Do not turn off it immediately. You have to check if this scanning is effective. Now, all the scanning jobs are finished, so let's move to the post-processing stage. Usually we download the files through Wi-Fi. You can connect your S2 to your computer with this 10.33 and 68 and 254 in the browser. You can also see this in the user menu. And when you enter this page, you can find the scanning task you did before and downloaded all these files to the PC. And here I listed 7 file types here. The FJD SLAM is the original raw data for processing, and INSV is the video files for colorizations. The FJD RTK is the RTK accurate geological data. The last PLY PDS are different point cloud file types. The RTCM is used in PPK, which is called post-processed kinematic. The PPK and the RTK are the same theoretically. The RTK is real-time processing and the PPK is post-calculating. Actually, mathematically, they are the same, just how they processed is different. And which way you choose to use depends on the actual situation. Sometimes you cannot get stable connections to the base. So in these situations, you can choose to use the PPK. They're the same. The final results are same. So here I want to introduce the main functions for point cloud processes. The first is point cloud mapping. You import your FJD SLAM file to create a point cloud model. And the other one is the point cloud colorization. You can, for S2 especially, you can import two INSV for external camera. And if you import the FJD SLAM, you can use the internal camera for colorizations. And this internal camera is also used in the real-time colorization showing on your scan. The other one is the RTK-based registrations. You can use this function to integrate accurate geospatial data into the point cloud. The last one is control points optimizations. If you have some accurate geospatial data on some special points, these points are also called ground control points. They can assist in more precise point cloud mapping when you check their positions during the scanning. Here, I want to talk about something on how to optimize results when working with S2. There are some tips may be useful in your future works. So first, from principles, I want to explain what is FOV. So this stands for the field of vision, which refers to the area that an imaging system, sensor, or human eye can cover in a single observation. The S2 has 360 degrees horizontally and 270 degrees vertically. As the yellow region shows, the S2 is suitable for horizontal grip, which means you can hold it horizontally without any tilt. But for P1, however, if you want a better data, P1 should slightly lift its head to form a 45-degree angle with the ground, which is shown in this recommended posture. This will give P1 a better view, a larger view, a better view, which will significantly minimizes the blind support effect. As I shoot here the right pictures, this is the S2 FOV, which is indicating that the S2 can see things like this. But in the meantime, the P1 has a blind spot in the middle. So if you target the things you want to scan in the middle, there will be something missed. Okay, and here are some universal scan methods. So the most important word you have to remember is constraint. The constraint is the basic principle of our advanced SLAM algorithm. I listed 4 things here. First, the narrow space. If you enter a narrow room, you can walk in and walk backwards. I don't recommend you to turn back your view. Just shift into reverse gear and back out. So, and second is for room change. Before entering a new room, make sure your scanner captures both sides of the point cloud, not only the new room, but also the formal corridor. For example, in this picture, new things are generated based on previous ones. So recklessly creating new things may lead to distortions and deviations. This is usually seen by me when somebody just send their data to me. I found there are some distortion deviations because you do not follow these rules. they are a little, maybe you can find a little tilt. The rooms are a little tilted, but if you do, as I said, this kind of errors or issues can be avoided. And the third, if a place is empty like this football field, try to add something, no matter it's large boxes, chairs, or even desks, or you can even let somebody stand there for reference, for a distance references. Because you add more things for scanners to capture the accuracy of the SLAM algorithm is improved. And the last one is for direction change. When changing a direction at a corner, you have to adjust your view slowly and smoothly. Please avoid making abrupt movements, just like turn left or turn right in 19 degrees. This is not recommended. Please turn slowly and smoothly to avoid steering abruptly. You can target your letterhead to the corner and slowly changing your directions. This is really helpful. And lastly, and I want to emphasize constraint again, please remember. So this page is especially for S2 scanning methods. First, you can keep a distance while walking. You don't need to head to the target and never get too close to the things you want to scan. And go straight. Do not walk in an S-shaped pattern like a snake. The distance should be controlled larger than 0.5 meters. This is the best range of the later detecting distances. So here is some tips for not only for colorizations, but also for the point cloud mapping. So I want to emphasize the first one, closing a loop to ensure perspectives remains the same from start to the end. Closing a loop doesn't just mean that you get back to the place you start or somewhere you have passed. The perspective should be the same as the past. So I suggest you to hold it in the center in front of you horizontally, and please let the scanner see what it has seen before. Do not just get back to the point that you have passed. This is useless. You have to keep the view the same too. And for the right holding the center suggestions, this is useful for the colorizations because you hold it in the center in front of you and do not make it tilted. This will make our block mask more efficient to eliminate your shadows or your colors to affect our scanner colorizations. So now here is the end of the useful skills sharing. Please remember the keyword constraint and remember the small tips like keep the scene view, back to the scene view and keep it in the center in front of you. This useful skills will do good to your future works. I really believe in that. And please apply them in your daily works. This will improve your data quality and your working efficiency. Lastly, I want to talk about the Trion model version 203. This is our latest model, and there are some new features and optimizations I want to talk. First, our point cloud mapping now support the S2 scanner. This is really useful for S2 scanner buyers. And here you can see there is a compatible mode. I want to explain this. So when the compatibility mode is turned on, the success rate of mapping scenes with fewer features or intense motions will be improved. But in the meantime, the solving or processing time will increase. This is designed for hard scenes. Sometimes there will be fewer features or less things, but we can also output point cloud for you as references. And point cloud colorization, this is also special for S2 scanner. It allows you to colorize point cloud with external camera or internal camera. And external camera is the same as the past models S1, S2, and S1 and P1. They are using the INSV, and the internal camera, which is using the FJD SLAM. And the pre-processing for S2 scanner, it enables you to efficiently process multiple data sets in a continuous workflow. This including mapping and colorizations, but they cannot be done in a row, in a single row. You can just do mapping when you're mapping and do colorization when colorization. And now we support a new effective data format, which is E57. It is compatible with E57 point cloud format now. And also you can export our last data file into E57 format for you to check in other kind of point cloud softwares like Autodesk Recap or other softwares, engineering softwares. And this chapter is for P1 version 1.6 and 0 firmware versions. There are also some new features and optimizations. So first, we support multi-selection download function. This can help you to select multiple files and download them in a batch at the same time. You don't have to choose one, and choose one again. This will eliminate your finger walks. And the other one is remote shutdown. Now you can turn off your scanner remotely on scan, and this extends the lifespan of the power button. You don't have to press it and press it again. The third one is fixed point marking. Now, when you are doing your scanning, you can mark a specific point when you working with the Insta-X3 camera. You can check the marked point in the fusion function in the FJD Trion model, which will support it on the version 204. We do not support now. We do not support yet now because this is now we have the version of 203. This is still testing, but this is really useful when you want to mark a point and export its data for the real-time view with colorizations. And the other one is for view switching. This is very easy with a button. Either switch between 3D and 2D views during the scanning, seamlessly adapting to your workflow needs. Just for example, if you're scanning a house, if you want to know if there is any houses left, you can just choose to 2D mode. If there is a blind zone, this might be someone you forgot to scan. And if you want to know how higher this room is to have a approximately calculating, you can choose to use the 3D mode, 3D view. And these functions you will see in a few weeks, I guess, because this is for firmware updation notifications. A pop-up will show up when there is a new version released. Actually, you won't see it until we release the version 1.7 and 0.1.7 and 0. Yes, so I hope the day will be earlier when you see this pop-up. Okay, thank you. So this is all our sharing today.